Okay, so in the first video we talked about a bunch of little pieces. We're going to kind of bring it together here into one concept, which we call probability neglect, which to sum up means we're neglecting in our decision making and our policy making when it comes to Homeland Security. We're neglecting what the probability of these types of attacks actually are. We're looking at the wrong things, and there's five aspects of this, and we're going to go through each one of them. The first is we love to focus on worst case scenarios. Okay, I think from a planning standpoint, from a Homeland Security standpoint, one of the absolute worst case scenarios is the detonation of a functional nuclear device in Manhattan or Chicago, or substitute any major metropolitan area. That would create a cascade of consequences that would be difficult for us to deal with on the spot, as well as difficult for us to recover from. It would cause untold billions of dollars in direct financial impact, as well as massive loss of life and casualties. You can't come up with a worse terrorist attack scenario than that. However, we use the threat of that to drive us forward. However, we don't actually really exercise that. We look at much smaller events. In the 12 years since 9/11, and all the years that I've been doing training and exercising in this field, we don't exercise or train the nuclear option because there's not much there to train or exercise. Yes, it's terrible. We'll deal with it if it ever happens, which the likelihood of it is extremely, extremely small. But we don't focus on the smaller attacks. We focus on that bigger event, and that is it's a failure in thinking on our part. Second item. Hopefully by now you're all familiar with the formula of risk equals hazards times vulnerability, where the numerical risk, if you will, is equal to the probability of a hazard occurring multiplied by the vulnerability of a specific target, population, city, town, or whatever. And these are all fairly arbitrary values. Different jurisdictions will use different numbers. The key is, if you're comparing, that everyone's using the same measurements across the line, okay? But that is, you basically take the probability a hazard is going to occur, a hazard being either a natural disaster or a specific terrorist attack, a variety of things, and you multiply it by the vulnerability, how much that hazard would impact the community, and that can give you a risk factor that you can compare and rank these things. Traditionally, for decades, it's been R equals H times V. This is taught across the board in every discipline that touches on disasters or emergency management. However, in the past 12 years, we've started doing something different. We've started adding hazards and vulnerabilities. So R equals H plus V, which can have some very interesting consequences, all right? There's an example slide in there where we're comparing a scenario of a terrorist bombing versus an F2 or greater tornado moving through a jurisdiction. So for the bombing scenario, we put the probability of this hazard actually occurring at 1. We put the vulnerability, in other words, how much damage it would do, a value at 60. And if we multiply that together, we get an R of 60. 1 times 60 is 60, all right? We compare that using the multiplication, the traditional method, to the tornado scenario. We put the hazard probability at 10. So we're saying it's 10 times more likely of a F2 or greater tornado impacting this community than a terrorist bombing having in this community. And in reality, it's not 10 times. It's probably 150 times more likely that a natural disaster like an F2 tornado will occur than a terrorist bombing. But for the sake of this, we're just going to use 10. But we put the vulnerability, the amount of damage that would be done to the community by this F2 tornado, at 10. So it's a lower number than the 60 of vulnerability of the terrorist bombing. But then we multiply them together. 10 times 10 is 100. And so if we're going to rank these hazards on this community, we would say, using a traditional method, that the F2 tornado with a risk factor of 100 is a greater threat to the community than a terrorist bombing. However, we don't multiply anymore. Now we add. So you take those same numbers, And for a bombing with a hazard probability of 1 and a vulnerability of 60, we get a number of 61. And with a tornado, we have the hazard probability of 10 and the vulnerability of 10. We have a number of 20. And so now, when we rank these on how we're going to spend our money and how we're going to spend our training and time, the terrorist attack has a higher rating at 61 than the tornado, which has a rating of 20. And this is just a simplified example of what's been done nationwide and statewide and community-wide all across the United States since 9/11. And it really shows why all of the spending has been on the Homeland Security piece and not necessarily focused on the natural disaster piece, which has a higher probability of occurrence. And we see this, the direct impact that we all witnessed would be Katrina in 2005, where in the 4 years between, or the 3.5 years between FEMA being absorbed into DHS and Katrina's impact in 2005, the response capability to natural disasters had been completely gutted as the focus was completely put upon response and preparedness for terrorist attacks, the Homeland Security mission, and that was justified through these types of mathematical changes. We're seeing this start to change back, but not enough. Third item that we do when we talk about ignoring probability is we work completely in relative risks. That's all we choose to assess. Yes, it is a greater chance that the city of Los Angeles will suffer a terrorist attack of some sort than Tallahassee, Florida. It is a greater chance that the city of Miami will suffer a terrorist attack than Tallahassee, Florida. Both of those have a greater chance of suffering a terrorist attack than, say, Perry, Florida. Okay? So we work in relative terms. And it's comfortable and it's easy. It's easy for us to create a list of 1 through 10 that we then can prioritize our funding on. However, none of that methodology actually assesses the numerical risk that any of those communities have of suffering a terrorist attack. All we focus on is which is a greater threat or a greater risk to terrorism and a lesser risk. We ignore completely the fact that in reality, all of them have a ridiculously low probability of suffering a terrorist attack. But that doesn't spend money. Okay? No one wants to spend money on something that has a 0.3% chance of ever happening in a given year. Okay? That's a waste of money, some would say. Especially if you take the terrorism component out and you're looking at just general funds being used for programs, and we'll say, you know, we'll set this $1 million aside for this program which has a 0.3% chance of actually being needed. How many taxpayers are going to stand by and say, what, you're going to spend $1 million on something that only has a 0.3% chance of ever being used? That is not going to sell to the public, so we don't talk about absolute percentages of risk. We use the whole relative ranking system. All right. We also tend to inflate the importance of potential terrorist targets. Critical infrastructure, key resources, these are great terms. They've got their own acronym now, CIKR. There's an entire field of study on security of CIKR and risk of CIKR, and it definitely involves the private sector. I think we've engaged on that topic several times here this semester. Yeah, no. See, the problem is, yes, some of this stuff is actually important. Let's look at the internet. This is one that people talk about all the time. What happens if someone attacks one of these major router centers on the internet here in the United States? Could they cripple the information superhighway? Wow, I just dated myself with that one. Could they cripple the internet worldwide, nationwide, whatever? And the answer is no, okay? They can't. You could pretty much wipe Austin, Texas, which has a large a number of routers and things in it for all these major backbone carriers in Texas, which would carry traffic from the East Coast to the West Coast. You could wipe Austin off the face of the planet and the world would go on when it comes to the internet. You can't just make it go away. The other thing that we talk an awful lot about is protection of our power grids, and there's a lot of talk about this, and I'll challenge you right now to go out and see if you can make sense of the concerns regarding the power grid security issue, particularly when we talk about electromagnetic pulse, both from weapons or from the sun or a variety of other things. You're going to see a lot of wild opinions on both sides, and not a lot of science, because really it hasn't happened since the 1800s, when we still were using telegraphs. But we talk about the problems with the power grid, and we look at the power issues that were created in the Northeast in ice storms and relatively large blackouts caused by human error. Great. Yes, these things can happen. Our power grid is aging. There's definitely some security concerns there. No, you're never going to be able to attack the power grid the way they do in movies such as, what's that one? Die Hard 4, right? Yeah, that's not going to happen. But you could, an attacker, through physical means, which has actually happened in California. There have been attackers using rifles to shoot at power transfer stations, hoping to cause blackouts. You could see a cyber attack against the power grid. How severe would that be? Okay, if you look at the way we spend money and the way that we prioritize, you would make it think that civilization as we know it would end immediately if someone succeeded in causing a regional or larger blackout. The reality is no. We've seen blackouts in the United States before. Okay, they can cause disruption, again, for a matter of days, and then suddenly the really annoying lights all come back on as the grid is repaired and brought back online, and it becomes a blip in history and really not something that we need to spend all this time worrying about. All right, and we do this across the board. Airports, oh my gosh, right? How much security do you see in an airport? How important is an airport, all things considered? Right? Maybe not so much. So we tend to inflate the importance of the targets that we perceive terrorists are attacking. And last but not least, we inflate terrorist capabilities. We make them out to be the ultimate threat to the United States that could kill or cripple large portions of the population or infrastructure of a variety of other things, and they haven't demonstrated that capability. 9/11 was a devastating attack not because of its complexity, because of its targets and its ingenuity. And in reality, it didn't cripple the United States long term. We've probably done more changes to our culture and society because of the attack than the terrorists ever did themselves. So we tend to overinflate their capability. Not to mention the fact it's been almost 13 years and we've not seen another 9/11 style attack. And again, we can circle all the way back around to the first question we asked in the very first video for this week is, are we safer? Yes. Yes, we are. Could we have the same level of safety for less money? I honestly can't answer that question. Nobody can answer that question. Everyone can speculate on it, but that's the entire point. We don't know what we've gotten for our money after all these years because we and our policymakers have been making decisions based on some seriously faulty assumptions. So let's keep that in mind.